All right, so we're going to cover some further characteristics of functions that we use to describe them, besides just the ones we covered, which would be domain and range thus far. Some will be a little bit familiar, and some will just be new terminology, but not necessarily difficult concepts. Notice that you're going to need highlighters or colored pencils. We're going to need at least 2 colors in order to complete these notes correctly. If you want to use colored pencils to add some other color, if that helps you, you can do that as well. There'll be opportunities for that. So on the front of your foldable, so when it's all closed up, these are the 4 topics we're going to cover by looking at the graph that is inside. So what you need to put on the outside, and these are the 4 corners, are the first topic is going to be intercepts. So one characteristic we use to describe functions would be their intercepts. What's called extrema, and extrema would be either a minimum or a maximum. And we'll talk about both of those. The idea of increasing and decreasing, whether your function is increasing or decreasing, is not a difficult concept, but it's we haven't necessarily put those words to it before. And then the last topic will be average rate of change. Now, you may be thinking, okay, we've covered at least some of that, rate of change in general, but average rate of change is a little, same idea, but slightly different. So on the inside of your foldable, this is what you should be looking at. And we're going to add things onto your graph as we add information. If things are going too quickly, remember you can pause the video in order to catch up and think about the pieces that we've talked about. So we're going to start on the top left, which should have been your intercepts. So when we talk about intercepts, now when we're doing lines, we're going to kind of compare things to lines. When we were doing just lines, we had one type of intercept, or sorry, one of each type of intercept. We had y-intercepts and x-intercepts, and that's going to be true still. But in this case, when we start talking about different kinds of functions, the x and the y-intercepts may not just be, or the x-intercepts in particular, may not just be a single value. The x-intercept, reminder, is the point where, and you should add this onto your foldable, that the x-intercept is the point where the graph crosses the x-axis. Now, this at this point, we call them just x-intercepts, but they do have other names. They may be called roots, they may be called zeros, they may be called solutions, so you want to add that on. So on my graph, and I'm going to use the color blue. If you have multiple colors, this isn't where I'm going to ask you to use the highlighters, but I'm going to add this in on my graph, so I'm going to color code it. So for x-intercepts, I see where I'm crossing the x-axis. There's one point. There's a second point. And there's a third point. So I actually have 3 x-intercepts here. So I'm going to go ahead and label that this is an x-intercept. And this one is -3, 0. I'm going to label this x-intercept. And this is 1, 0. And I'm going to label this x-intercept. And this is 5, 0. So we have x-intercepts where the graph crosses the x-axis, where the function value, the output value, is equal to 0, where our y value is 0. And then you have the y-intercept where the graph crosses the y-axis. So I'm going to change colors, and I'm going to mark on my graph. It looks like my y-intercept is right about there. So I'm going to add it in, and it crosses the y-axis at the point, there's the y-intercept, at the point 0, 2. So where my x value, where my input value is 0. Okay. So x and y intercepts not something brand new. We've definitely done that before. But just realizing that we may have different amounts of those as we increase the difficulty or complication of our. All right, our second characteristic that we're going to go to the bottom left side here, which is the one we labeled as increasing and decreasing. Now, increasing and decreasing is a new topic, but not completely new. I almost think that you could probably guess on our graph when we're talking about increasing and when we're talking about decreasing. But as far as the definition, and here's where I'm going to start using my highlighter. So I'm going to get a highlighter and I'm going to use yellow here. So a function is increasing on an interval. So interval, remember, just means like from from starting at a certain value, ending at a certain value, and all the values in between it. It's increasing on an interval if the y value increases as the x value increases. So what I want you to think about is the directions here that we're talking about. If the x value is increasing, we're going to the right. And if the y value is increasing, we're going to be moving up. So what sections on my graph have a y value that's going up as the x value increases? So you always want to read from left to right. So the first section here of the graph that I'm highlighting in yellow, this section would be an increasing section up until it hits that top point, because the graph is going up as we move to the right. Now, once I hit that top here, I'm going to go back. I'm actually going to be going back down. And then when I hit this bottom point, I'm going to be heading back up. So this graph actually has two sections where we're increasing. And I'm going to add labels to this as well. So this is an increasing section, as well as this section. As I'm moving to the right, I'm also moving up. You can also think of the increasing section as something we've seen before. Even though it's not a straight line, you can think of it like having a positive slope. A positive slope is an increasing function. So then that means a decreasing function. I'm going to change my highlighter, and we'll go with an orange here. I'm going to say my function is decreasing on the interval, and notice the definition here. If the y value decreases as the x value increases. So we're still moving as far as the x value increasing. We're still moving to the right, but this time we're moving down. So when you're judging increasing and decreasing, you always want to think you're going from the left side to the right side. So decreasing, I'm going to go ahead and highlight this section of my graph, and I'm going to put a label on there to describe this as decreasing. So our function, if we were going to say where it's increasing and decreasing, what we would use is we would use inequalities. We could use the same sort of notation we use for domain and range as we used for as we are going to use for increasing and decreasing. So for instance, for decreasing, it starts decreasing, the tip top here, -1, the bottom here is at an x value, and I'm just looking at the x values here, of +3. So if I were going to say that this is decreasing, I can say it's decreasing from, it starts at -1, and it goes all the way up to +3. So just kind of realizing the notation that we're going to use is the same as we would use for domain to talk about where our function is decreasing. Now, why are we using the x values instead of the y values? Why wouldn't I say it decreases from 4 to -4? The reason is if I say decreasing, I already know that my y values are going down. I want to identify where the x values are that have that effect on the y value. Okay, so increasing and decreasing on our graph. Let's talk about maximum and minimum, or extrema. So the local maximum, we call it a local maximum because it's the y value, or the highest y value, highest point in a particular region, a particular area. It doesn't necessarily mean that it's going to be the highest y value on the graph. For instance, the graph we're looking at right now, if I were to ask you what the highest y value is, well, you have this arrow on the end. It's going to keep going up and up and up forever, so it's not necessarily going to have a number that is the highest y value. So a local maximum would be a peak like the one you have at the point -1, 4. And what I want you to notice is it's the y value of that location. So we would say for this point, and I'm going to write it up here so we can see it more clearly, that there's a relative maximum, oh sorry, not relative, we're using the word local, a local maximum at x equals -1 of 4. The y value is the maximum. You can say where it's located by using the x value, but generally speaking, we say that the local maximum or in this case, the local minimum, we're going to do also the y value of the lowest point in a particular reason, we identify the y value. So this is, I'm going to change back to black so that you can read it more clearly. This is a local minimum at x equals 3 of, the local minimum itself is how low did we go? We went down to -4. So as far as characteristics go, these are mostly familiar, but perhaps just not things that we've named in specifics. The words increasing and decreasing, local maximum, local minimum. It's not that they're hard definitions, it's just we haven't. So the last characteristic we're looking at is average rate of change. For average rate of change, what the average rate of change is it describes the average slope of a function over an interval. So you'll notice, and if you look carefully, you'll notice that even this function is not made up of straight lines. So when we're talking about average rate of, or when we're talking about slope, we're talking about just straight lines. When you talk about the slope of a curve, or slope of a curve, it's going to change over time. So we're talking about just the average value. On average, what is the slope if we measured all the different slopes over an interval? The the formula for average rate of change is the exact same as how we think of finding slope in general. So the slope formula or the average rate of change formula is still the change in the y value over the change in the x value. So I'll be subtracting my y's, or my, if you want to say, f of x2 minus f of x1, now that we have that function notation. But I'm going to subtract my y's over subtracting my x's. So for instance, we're going to do the average rate of change here. And we're going to do it from, we're going to pick 2 points on our graph. So I'm going to pick a point here. I'm going to pick the point, and that is -5, -5. And then on the other end, I'm going to pick the point, let's find a nice clear point. Let's pick this point right here. So that point would be 6, 3. From -5, -5 to 6, 3. So if you notice from those 2 points, I have an up, I have a down, I have an up. So what I want to know is overall, what was the effect? What was the average slope between those two values? So I do it the exact same way that I do my slope value. So average rate of change would equal the change in the y value. So if I go 3 minus -5 over 6 minus -5, I would have 3 plus 5 is 8, 6 plus 5 is 11. The average rate of change, so if I were to draw a straight line and kind of describe in general what's happening, overall we have more of a positive slope because look, we are overall increasing from my beginning point to my ending point. So it's describing over time, and how we use this is really when we're modeling. It's saying like over time what on average is happening. So imagine this was maybe the function itself is showing what's happening in the stock market. Over time, so if time was X and like the value of a stock was Y, you would be able to say on average what is happening, instead of worrying about every single little up and down change. So these are our basic function characteristics that we will be practicing identifying off of various functions.